I have a feeling today's will go very quickly and efficient because we basically already did it yesterday. Yeah, so separation of variables is just a method for finding general solutions. And for the most part, it's just making sure that you write things correctly when you integrate. I mean, like, the overall picture is no different than anything we've done. So if I look at A, we have a differential equation, and our goal is to find a general solution, which we kind of already know means to integrate. Well, integration doesn't work unless it's set up nicely and correctly ahead of time. So quite a while, I think it was 7.1, we talked about how you have to multiply both sides by dx. And we specifically do that so that the dy and the dx are in the right spots. Why are you guys still talking to each other? I wanted to get through this. We have a shortened hour today. Want to make sure we're done. No, put your food away. Get out your note packet. I kind of did that yesterday too. If I only multiplied by the dx, then we currently don't have everything in the correct spots. We can integrate the left-hand side the way it sits. That's not a problem. But the right-hand side isn't just x variables. So we would have to move or get rid of this y to be able to integrate. And we talked about this yesterday already specifically. I think it was one almost exactly like this. We would have to multiply both sides by y to cancel off that y, or to move it, however you want to think of it. And then we would have y dy equals 2x dx. Separation of variables is just literally moving the variables so they are on the correct side. Now, one thing you're going to find, this only works with multiplication and division. We're only able to move everything that way. You're not ever going to have like a minus 3x. Or no, how should I say that? You're not going to have a minus 3y, because the minus 3y wouldn't be on its own. It would have some sort of a dx or dy attached to it. So you're not going to be able to add it to both sides. So the equations that we can do will only be able to be worked with multiplication or division. And so it's usually fairly straightforward. There traditionally is a separation of variables question on free response every year. And it's not the fact that it's difficult to do. They just want to know that you are not intelligent enough. They want to know that you realize variables have to be grouped together correctly to be able to integrate. And so they traditionally give you a full point out of, like 1 point out of the 9 points, just for taking the steps of rearranging things. And on their scoring guide, it says +1 for separation of variables. So every single year you guys can get at least one of the 45 points just because you knew how to write that, even if you didn't get the answer correct. So on free response, the troubles we've had in previous years is everybody looking at a problem, feeling like it's too difficult, giving up, going on to the next question. But the way their scoring guides work is they give you points for whatever portion you do correct. So even if it's a ridiculous equation and you don't know how to integrate it, the fact that you would rewrite it so that they're grouped together means you would get some of the points. And same with the plus C. Frequently, they'll give you a point for writing plus C, even if your answer's wrong. Now, there definitely are times where they tie together the correct answer and the plus C, but still, I've seen it where the plus C was its own point. Do you want me to finish this one with you guys?
Yes, please.
Okay, so we would integrate both sides. And you basically don't pay attention to the variable itself. The integration is the same for every variable. So this, in your head, if you need to, think of it as x to the first. So if I integrate y, I get 1/2 y squared. 2x, oh, I did not write plus c because you only write plus c once in a problem, in a line. You can write it twice, but it just makes extra work. Integral of 2x, I think you probably already know is x squared, but same thing, it's power rule. And then we would write plus c. Most people write the plus c with the x because frequently you have to solve for y. Now, I have heard, because I think Mr. Stouffer's class with Derek did this one yesterday, I've heard the answer key frequently writes the final solution differently than you would. So I guess what I want to emphasize now, there's going to be lots of ways to write the final answer. It doesn't tell you to write the general solution in any particular form. This would be one general solution. If you have to, most people solve for y, if you can. But if solving for y would create a plus or a minus, then you generally leave it as like y squared. So this I would leave as the final answer on free response because it's the general solution. I guarantee an answer key probably doubles everything and moves the x's over. So it probably has it written differently. So negative x squared plus half y squared equals c. You'd multiply everything by -2, I guess, so that the x squared is positive. Oh, I forgot to write squared. And this is probably what a multiple choice answer would show. But free response is great because you could just leave it in whatever form you want. You can leave it as messy as you want. And you have less chance of errors if you don't do extra steps. Like the fact that I forgot to write that squared. I would have gotten that marked wrong because I forgot to write the squared. You just basically leave it wherever you can.
Can we get points off if we don't simplify on the free response?
No, not at all. They don't require you to simplify. That's actually why I like, that's the one nice thing about free response. They allow you to write it any version of the correct answer. Okay, should we go to a harder one or should I have you guys try B on your own first? B? Oh, all right. So I definitely got some people wanting B first. Try B on your own. See if you can get that answer relatively quickly. Josh, you're still on your phone. This was yesterday too. Got to follow along. But James is up today. Excellent. Jasmine, oh, you're feeling brave. Would you mind writing your answer up there?
I'm not done yet.
Okay. Or should I ask if anybody wants to write theirs up there rather than like calling on somebody? Does anybody feel like they got it right? Or is there a difficult part towards the ending? I don't know what that answer means. You're trying to say a lot of different words but not saying anything. Okay. Okay. Thank you. Oh, you literally just wrote your answer. Okay. It's not wrong. I mean, that is what I said. I meant the work too, but I didn't say that. So that was my fault. Did a lot of you get that same answer? Okay. Now, this is where it's weird and dumb. Traditionally, if you can solve for y, you're supposed to. But, like I said, on free response, it doesn't matter what form your answer is. So if this was free response, you could leave it like that. However, for your homework, you will definitely not see that answer. So you would most likely have to multiply both sides by negative y or something, because we're trying to solve for y. The plus c is where it gets kind of weird, because the plus c is going to be on the bottom. And there's, how should I say it? There's a variety of ways you could finish this problem. In my opinion, none of them is more correct than anything else. I myself would also leave it like this. But for the most part, a lot of people would probably multiply both sides by y, divide both sides by x plus c. Or excuse me, multiply by negative y. And then divide both sides by x plus c. And that's probably the most simple answer.
I did not get that at all.
You did not get that at all? Oh, okay. What'd you get?
1/2 natural log absolute value of y squared equals c.
Say it again. 1/2 natural log.
Absolute value of y squared equals c.
I think you.
You integrate it again.
No. I'm pretty sure that when you were at this step, when you integrated that, you made it natural log probably?
Yeah.
So you were thinking of 1 over y. So 1 over y when you integrate it as natural log.
Oh, wait, yeah.
1 over y squared is deceiving because we do so much natural log. 1 over y squared you would treat as y to the negative 2. Yep. No, I understood what you did. And we definitely are going to have natural log ones in this section. So be prepared for that. The only reason this one wouldn't work for natural log is because the top isn't the derivative of the bottom. So if there was a y on the top of some sort, that would be natural log. I suppose I should do D with you because it's written differently. Yeah, go ahead.
Did the deal around the top turn just one when you integrate it?
This dy?
Yeah.
It should read 1 over y squared dy. And then when you integrate this, the dy goes away. So you need the dy to be able to integrate, but it won't be part of the answer. So if I'm understanding you correctly, the right-hand side should have been the integral of dx. And this is like saying 1 dx. So that answer would be 1x.
Okay.
Yep. I'm going to skip C because it's kind of same as the other ones. Except for, actually, no. You know what? We better do C because I know the answer needs to be talked about. The integration's not hard. The answer is. You get dy over y equals x dx. Integrate. You will get natural log absolute value of y equals 1/2 x squared plus c. Yep, we're getting there. I'm waiting for people to catch up. It's the final answer that you need to know how to do because it's part of 7.4.
Can you just write like, do you have to write like the absolute value signs or not?
Simple answer, short answer is yes. If for some reason in the problem they gave you domain restrictions to start with by saying y could only be positive, then you wouldn't. You always put the absolute value just to be safe for the most part. I'll explain how we get rid of it in a second. Are most of you okay with this step right here, probably? Otherwise, does anybody want me to explain where the natural log came from or anything like that? Okay, so dy over y is the same thing as writing 1 over y times dy. And the integral of 1 over y is, well, it's sort of the definition of natural log. The derivative of regular y is 1, so the derivative's on top, even if we need to do u substitution. If you see derivative over original, that's supposed to be your key to recognizing when you do natural log. And so you should get absolute value. And yes, so our goal is to solve for y. On the AP test, I have noticed that they make you solve this one for y, but not other ones. I'm not sure the difference to them, but I have noticed they make you solve this one for y. So that's why it's important we go over it. Is that the way that they taught you in pre-calc then? You take both sides e to the power of? Okay, that works. To me, it's weird, but it's not wrong. I don't know, that one seems strange to me. So the e and the natural log essentially cancel each other out because this is log base e. And that would leave absolute value of y equals e to the 1/2 x squared plus c. Not yet.
Is it possible to just break the C down?
I'm getting there. You're never going to see this written out. Let me refresh you on power properties. If you have two same bases being multiplied, you add their powers. Okay, I wrote that backwards. So you add their powers. What we're going to do is backwards. We have powers being added. So we're actually going to change this to say e to the 1/2 x squared times e to the c. And this is where it gets kind of weird. Remember how I tried telling you if you multiply c by a number, they just write c instead because it's still a number you don't know? Yeah. This is the same, along the same method. E to some power you don't know is still some number you don't know. And so they take that whole thing and they just write that as c instead. So c basically absorbs everything somehow. It's like some sort of superpower. So the thing turns into absolute value of y equals c times e to the 1/2 x squared. I mean, it's not wrong. It's just kind of math is weird because for most things, its rules are very specific, very particular. But when you're talking about a c value that you haven't figured out yet, they basically become super loose on the rules, and everything just turns into a new c.
The way I saw it was you would go from capital C to lower C.
You can change the number on it, you can change the variable, but they don't make you. Okay, last step. Does anybody remember what happens when you take off an absolute value symbol? It turns the other side into plus or minus. Well, if you multiply the c by a positive or a negative, it's still c. So that's why they appear to just randomly take off the absolute value symbol. But they don't randomly take it off. It gets absorbed into c because you're going to figure it out later anyway. So you are going to have a few of them today. When you have to do natural log of y, your final answer looks like that. And if I wouldn't have gone over this problem, you probably would have been extraordinarily lost looking at the answer key.
There's also one in homework yesterday.
That doesn't surprise me there was one in the homework. I know there was a natural log, but did the answer have a C written in the front like that?
Yeah. And then they
Oh, it
solved
did. Oh, boy. Yeah, it doesn't surprise me. The person that created these packets likes to introduce problems for the next section. I know there's a problem in our homework for this section that directly goes to the next one. How are we feeling on this one? This is by far going to be the most difficult part of separation of variables. No, it's not too bad. It's just strange. Bless you.
Very violent.
It definitely seemed like it. It was like a sneeze cough. I didn't even think that was like physically possible. Aman, let's get you involved. How would I start example 2? Oh yeah, I wanted to do D. Good memory. Sorry. I wrote in D and I was thinking in my head that we did D. Okay, D I only wanted to show you because it's written differently. That's all. So here's the issue I have with D. The notation, the way it's written, you're allowed to just do that. Because y prime is the same thing as dy. And so officially, we don't have to do anything with this problem. I do know that this problem is in here for one specific reason, and that's to show you that notations are different. So I know this is not the intent, even though, in my opinion, that's totally okay to do right away immediately and then be done. I know the intent of the problem is separation of variables, and so you would move the x to the other side, which it's not wrong. And then y prime is the same thing as dy dx. So the type of notation you use sort of depends on how you approach it. I mean, like, it's technically x prime is 1, so nobody ever writes x prime. That's why x prime isn't physically written in the original problem. But if x prime was written there, the variables would have been correct and ready to integrate. If you switch it to Leibniz notation, which is dy dx, then you have to separate variables and multiply to move them around. The actual integration on this problem isn't difficult at all. It's just the fact to show you that y prime is the same as dy dx. And whichever method you choose to write your problems as, you have to approach it that way. So if you write it as dy dx, well then make sure you separate them. If you write it as y prime, then it's kind of gray area.
So if this wasn't an FRQ, could we just...
My guess is on the FRQ, they won't even give you the possibility of gray area. They would not write it as y prime. Because y prime is usually accepted as dy, and then you would be allowed to integrate directly from there. Many textbooks don't write dy dx. They just write y prime. So the notation you choose kind of dictates how you approach it. The actual integration wasn't bad or terrible on this one at all. I just wanted to show you that the way you choose to write it matters. Okay, Aman, back to yours. How would you start number 2?
You find the integral of 3y squared dy.
So you're basically saying to rearrange things,
Yeah.
okay, which is correct.
That equals integral of x squared plus 1 dx.
Yeah, you skipped a couple steps, but you're not wrong at all. Absolutely. And then whatever you get from that. honestly, I wasn't going to talk too much about the integration itself today because you guys should be pretty good at it by now. What I wanted to focus on was the parts that we haven't seen before as much, which is moving them around. It seems like you guys are pretty okay with that though. Let's try this top one then. What I would like you guys to do is integrate this, or like find the general solution on your own, and then we will talk about what this says afterwards. So just find the answer that says plus C. See if you can do that on your own.
Yeah, I don't think
Oh, that's a no? Do I need to help you guys set it up to start?
maybe,
Okay, what looks difficult about it?
maybe like E to the negative T.
Okay. Well, our first goal is to move things so they're on the correct sides. Doesn't matter if it's an X, Y, T, whatever variable they give you. So first thing you want to do is move things around so they are on the correct sides. Looks like I need to do that with you.
Yeah.
Trying to find people on their phone. I like this. I do not see somebody on their phone. James, I'm not even gonna. Your phone. You've gotten picked on enough, so I don't want to like pile on. Oh, okay. Ava, how do I know which side is going to represent which letter? So the dxdt is what tells us, guarantees us which side is which.
Well, the dx on the x, and then you get a negative.
Okay. Yeah. Okay, you gave me the obvious answer, which was definitely correct. How do I know in this current setup x would have to be the left, t would have to be the right?
Be like positive?
No, I'm trying to think how to phrase the question without direct giving the answer.
T's like in the denominator? So
Yes.
like that or something?
Yep. Should I have just called on Vivian?
Yeah.
Okay, she's the expert now. We'll just call on her. Oh, okay. I'll let you be the silent expert. We have to multiply by dt because it's in the denominator. That's what guarantees us which side has to be what. dx is already in the top, so that it has to stay there. The d, whatever variable you have, can't be on the denominator. So I multiply both sides by dt. I obviously need e to the negative t on the other side. There's multiple ways we can do this. I'm trying to think what you guys would have been shown in pre-calc. We could divide by e to the negative t.
Times 1/3 E to, or times E.
What does the negative power represent in the first place anyway?
So we can multiply by E to the T.
So we could have written it like this from the start, and then we would multiply both sides by e to the t. Dividing by e to the negative t would just put a negative power in the denominator, and then you would move it to the top as positive. There's a lot of ways to work with it. Either way, we end up with x dx equals e to the t dt. Bless you. Now the notation here is in function notation. But this isn't written in function form. But in function notation, what does the number in the parentheses represent? The other variable. It's like when we write down y of 3, we put 3 in place of x. So this notation means I'm going to put 0 in place of t, and the answer for x is 1. So this is kind of like telling me the point to plug in to figure out c. It's telling me put 0 in place of t. And then I'm going to put 1 in place of x. So this will give me half equals 1 plus c. Negative half? Why is that so hard in my head right now? Okay, so then once you figure out c, this asked us to find a particular, actually it didn't even use the word particular, but it should have. The particular solution would be this, where you put negative half in place of c. There are a lot of correct particular solutions. We could double everything, and this would say x squared equals 2e to the t minus 1. You could theoretically solve for x, but we probably wouldn't because that would create a plus or minus. There's going to be a lot of ways to write it. The multiple choice part of that is it's hard for you to take your answer and match it up to multiple choice. Free response is nice because you kind of have the freedom of how you want to write it. I'm trying to find one that gives natural log again. Oh, that's it. Which one should we try? 4? Is that because it looks easier? Oh, I thought we would pick the harder one. Oh, okay, that's actually good. I wanted you guys to try this one on your own. See if you can get to it. So, when you're right, the x being in different spots, first of all, just start by figuring out which side has to be which letter. And then try to figure out a way to rearrange them so that works. Don't worry about the y1 equals negative 4 until you're done. Oh, we're doing 15? Actually, that'll work out perfect. This one appears difficult, but actually has very little work to do to separate them. It's because the y isn't really tied together with anything else. You have your choice in how you want to approach 1 plus x over x. I usually prefer to separate the fraction. Some people like to bring the x up and multiply it out. Kind of your choice. How are we doing on that? How many people ended up with that answer? That's pretty good. I was assuming if somebody got stuck, they'd probably get stuck on the part trying to figure out how to get rid of the y on the right-hand side. And at first glance, it does seem like it would be confusing because like the x is in different areas. But the x's were supposed to be on the right, which is what saves us. So you just multiply by y. And or the integrating of 1 plus x over x. It's been a little while since you guys did like different types of integrating, so maybe you forgot about that one. But having a monomial in the denominator usually is an advantage because you can separate things. Okay, that's probably all the farther we'll get today. I mean, we only have 7 minutes left. Again, when you're doing your homework, I attached the answer key already because we're kind of at crunch time, so it's not like I'm going to delay you an answer key or something. Most of the answers are written differently than probably how you're going to, but it's good for you to take notice of how it was rearranged and written for multiple choice purposes. For free response purposes, do know that lots of answers are correct. Yeah.
Look at work day tomorrow.
Can we?